To understand clearly our lesson for today, you must be familiar with graphs of different kinds of functions. The graph of linear function is a straight line. The graph of a quadratic function is a parabola that opens upward or downward. This is an example of graph of a polynomial function of degree greater than 2. Watch the nature of the graph of square root function. This is absolute value function. The last one is a piecewise or split type function. With this simple recall of graphic concept, you may easily grasp our topic today. Have you heard about limit? Every time we cross bridges, we can observe warning signs like this: weight limit 32 tons, which means that a vehicle exceeding 32 tons cannot pass or else the bridge may collapse. So, the warning signs tell us the limit. Similarly, let us consider the spring balance. If we put the standard weight to spring balance, we can observe that it almost reaches its maximum capacity. What about if we add these 3 more standard weights? What do you think will happen? Of course, the spring balance will be destroyed. Why? Because it exceeds the limiting capacity of the spring balance. What I have shown you only prove that there are a lot of things around us which has limit that if we go beyond the limit, it will simply cause trouble. Just like what you have seen, there is also limit in mathematics. Let us determine the concept of limit with this activity. Let us consider a circle . Let us draw an inscribed polygons in this circle. Let's say hexagon, if we consider the measure of the perimeter of the polygon inside the circle, what do you think? How does the perimeter of the circle compare with the circumference of the circle? Let us observe the perimeter and circumference of the inscribed polygons. The results show that in 4 circles, the perimeter is always less than the circumference. If we will consider the difference between the circumference of the perimeter, of course, the difference still becomes smaller and smaller. If the process is indefinitely continued, of course, the differences still become less and less, and the difference approaches a certain value, which is 0. We can say that the perimeter of an inscribed polygon cannot be equal to the circumference of the circle, or in short, the limited polygon as n approaches infinity is the circumference. Let us now formally define the limit of a function. Let y equals f of x be a function. Suppose that a and l are numbers such that as x gets closer to a but not equal to a, f of x gets closer and closer to l. Then, we say that the limit of f of x as x approaches a is L. To better understand the concept of limit of a function, let us consider this example. The function is f of x equals 2x plus 1 and let a equals 1. Let us examine the value of the function as x approaches 1. We are interested in the values of x nearest to 1, but not equal to 1 from the right and from the left. As the value of x approaches 1 from the left, the value of the function approaches 3. Similarly, as the value of x approaches 1 from the right, the value of the function also approaches 3. Numerically, in both cases, as x approaches 1, the value of the function approaches 3. Intuitively, we say that the limit of 2x plus 1 as x approaches 1 is 3. The limit of y equals 2x plus 1 can also be shown in the graph. Pay attention to this. Graphically, it also shows that the limit of 2x plus 1 as x approaches 1 is 3. You can try answering these problems. With this video presentation, I hope that you learned a lot about limit. Thank you!